Have you ever stopped and wondered how a surgical robot makes a perfect incision? Or how one of those warehouse bots just knows which box to grab out of thousands? Well, they're not just following some simple pre-written script. They are actually thinking. They're planning. They're creating a roadmap in real time. And today, we're going to pull back the curtain on the invisible engine that makes it all happen. The AI that plans every single move.
Right. This is the fundamental puzzle of robotics, isn't it? At the end of the day, a robot is just a collection of metal, wires, and motors. It's an amazing piece of hardware, for sure, but without a brain, it's basically just a very expensive paperweight. So how do you take that machine and turn it into an intelligent partner that can actually navigate our world and get things done? Well, the secret lies in a really powerful digital navigator. And that navigator, of course, is artificial intelligence. You can think of AI as the robot's brain. It's what provides the two absolutely critical types of instructions that guide every single action the robot takes. Let's break those two down.
Okay, first up, we have motion planning. The easiest way to think about this is like the robot's own personal GPS. It's all about figuring out the physical path. It calculates the most efficient and, this is key, collision-free route from point A to point B. It's what makes sure the robot's arm doesn't just slam into a table on its way to pick something up.
But just having a path isn't enough, right? The robot also needs to know what to do and, just as importantly, in what order. That's where task planning comes in. So if motion planning is the GPS, task planning is like the recipe. It takes a big, high-level goal, like, say, assemble this chair, and breaks it down into a logical, step-by-step to-do list. First, pick up the leg. Then, align it with the seat. Then, insert the screw. It's all about the sequence of actions.
And this is where it all comes together. Looking at them side by side, you can really see how they're two halves of the same brain. Motion planning is all about geometry and physics. It's the path. It answers the question, how do I physically move my arm from here to there? Task planning, on the other hand, is pure logic. It's the to-do list. It answers the question, should I grab the object before I try to lift it? And you absolutely need both working together to get a truly smart, useful robot.
Okay, so that's the theory. But where is this robotic brain actually making a difference out there in the real world? Let's take a look at how this stuff is being used in some of the most demanding environments you can imagine.
And we're going to start in a place where there is absolutely zero room for error, the operating room. In here, a robot's plan isn't just about being efficient, it's about patient safety and the success of a life-saving procedure. I mean, just look at how critical AI planning is here. The AI can create a totally personalized surgical plan based on a specific patient's unique anatomy from a CT scan. It can plan the perfect, steadiest path for a biopsy needle, or chart out the exact cutting paths for a delicate spinal surgery. And it's not just a static plan. It can adjust its movements in real time. This is dynamic intelligence where it matters the most. All right, let's switch gears. We're going from the quiet focus of the OR to the nonstop 24/7 hustle of a modern e-commerce warehouse. In this world, the challenge is all about speed, massive scale, and some truly mind-boggling coordination.
Yeah, so the key thing to understand here is that the AI is basically the orchestra conductor for an entire fleet of robots. It's not just planning a path for one machine. No, it's coordinating hundreds of them, making sure they don't crash into each other. It's figuring out the smartest way to batch your orders to save a robot a trip across the building. It's planning the most efficient little wrist flick to grab an item off a shelf. And it's doing all of this while adapting on the fly to a warehouse that is constantly changing.
Now let's move over to the factory floor. Robots have been a staple here for decades, right? But AI planning is giving them a whole new level of smarts, letting them take on really complex assembly tasks that need both logic and a delicate touch. This slide really shows that robotic brain, both sides of it, working in perfect harmony. Step 1, you see, is pure task planning. The AI looks at all the parts and figures out the logical order to put them together. Then, steps 2 and 3 are all motion planning. It explores all the possible ways the arm could move, and then it picks the best one and turns it into a perfectly smooth, elegant trajectory. It's this beautiful fusion of logic and geometry.
So, all those examples we just saw, the surgery, the warehouse, the assembly line, they all happen in pretty controlled, well-understood spaces. But what happens when a robot has to go, off-road, into a place it has never seen before? Well, this is where the AI brain has to get truly adaptive.
And the key technology here is this incredible thing called SLAM. It stands for Simultaneous Localization and Mapping. And honestly, it's as cool as it sounds. A robot using SLAM is like an old-school explorer drawing a map of a new continent as they walk through it. But at the same time, they're constantly putting a little "you are here" pin on that map they're drawing. It's what allows things like autonomous rovers or those cleanup boats in harbors to navigate and work in places they've never been.
You know, even within motion planning, different AIs actually work as a team. Think of it like this. An algorithm like RRT star, that's like a scout that has to bushwhack through a super dense forest just to find any path to the other side. The path might be messy and inefficient, but hey, it proves a route actually exists. Then an optimizer like DMP comes in. It's like a team of civil engineers that looks at that rough trail and paves it into a smooth, multi-lane highway, the most efficient, perfect route possible. It's this two-step process, from possible to perfect.
And this whole field is just moving at lightning speed. The new AI toolkits are just incredible. We have robots using reinforcement learning now, literally figuring out the best way to do something through trial and error, just like we do. These huge foundation models and LLMs are making task planning way more robust. And things like knowledge graphs are giving robots actual context. So if something goes wrong, they don't just freeze up. They can understand the situation and figure out how to recover.
So, let's zoom out. We have robots that can plan what to do, how to get there, and even adapt and learn in brand new situations. What does this incredibly sophisticated planning ability really mean for the bigger picture, for our future?
I think this quote just nails it perfectly. We see the robot arm moving, the machine gliding across the floor, but what we don't see is that incredibly complex web of calculations, simulations, and logical decisions happening every single millisecond inside its digital brain. This combination of motion and task planning, it's the unseen, unsung hero. It's the software breakthrough that is finally unlocking the true potential of all this amazing hardware.
And all of this leaves us with a really fascinating question to think about. As these AI planners get exponentially more powerful and robots start taking on tasks we can barely even imagine today, it completely changes our role in the equation. The new frontier isn't going to be about just telling robots what to do. It's going to be about how we collaborate with these intelligent planners to solve even bigger challenges, together. And what that partnership is going to look like, well, that's one of the most exciting questions of our time. And now you know what's happening inside that robot's mind as it figures out its very next move.